So we'll first find the time derivatives of the Euler angles. And the time derivatives will be a function of this Euler angles at the previous time instant and the angular velocity of the body frame, the alpha frame, the object frame with respect to the reference frame, and resolved along the alpha frame. Okay, now to find the time derivatives, what we'll do is we'll show all the three rotations in one figure. Last time we showed one rotation at a time. Now we are going to show all the rotations, all the three rotations together in one figure. So let's start with the initial coordinate frame. First we'll have a yaw rotation about the z-axis. This is the yaw rotation rate, psi dot. Since we are applying the rotation about the z-axis, the vector psi dot is along the z-axis. And the angle by which we are rotating the frame is psi. Since the rotation is applied about the z-axis remains unchanged. After the rotation, x and y will change, so let's use a different color to denote the new x and y. This is y1. Psi. Right. The second rotation is about the y-axis, and we are applying a positive rotation. So using the right hand thumb rule, this is the direction of positive rotation, and this vector is theta dot. Pitch rate theta dot, and we are applying the rotation about the y-axis, so y-axis remains unchanged. This time z and x will change their orientation. So this is the new z, and this is new x. This angle is theta. Don't think that they are all in the same plane, okay? We are showing 3D in 2D, that's why they appear to be in the same plane, but actually they are not. The third rotation should be about the x-axis. Rotation rate is phi dot. X-axis will not change. Y and Z will change. This angle is phi. So we have shown the directions of all the three time derivatives, psi dot, then theta dot, and phi dot. Right, and our objective is to find the expressions of this time derivative. And we know that we have been given the angular velocity vector omega. So this is the component of the angular velocity vector about the x-axis. This is about y-axis, this is about z-axis. Now we also want to show these components in the diagram. So let's use the other notations PQR and use them in the diagram. We also want to show PQR and PQR is basically equal to this. So can you tell me along which axis I should put PQR? So we are going from beta frame to alpha frame. The first frame, the initial frame was beta frame and the final frame is the alpha frame. So along which axis should I put PQR?
X3, Y3, Z3.
Yes. So I'm just showing this way so that you can easily identify PQR, X3, then Y3, and then Z3. So these are the directions of PQ and R. Okay. Now let's find the expressions of PQ and R first. Okay. So let's consider P first. Next we are going to write the expressions of P, Q and R in terms of phi dot, theta dot, psi dot and the other angles phi, theta and psi. Okay. So P is equal to, we know that phi dot is along x3, so phi dot will be there in this expression, correct? What is the other term we will have? There will be one more term. Okay. What is that term? Can anybody tell me what that term will be? Some of you must have done this in other classes. Yes or no? Have you done this before? You can't even say yes or no?
No, ma'am.
You didn't do this. You didn't find the derivatives of other angles in any other classes? Okay. How about psi dot? will it have a component? Now psi dot is along z0 and z0 is the same as z1, correct?
Yes, ma'am.
What can we say from this? So psi dot is perpendicular to y1, right? And psi dot, because z1 is perpendicular to y1, correct? And psi
Yes.
dot is also perpendicular to y2 because y1 and y2 are the same. Yes or no? yn and y2 are the same, right? So
Yes, ma'am.
psi dot is perpendicular to y2 also, correct? So this means psi dot will have two components, one along z2, another in the opposite direction of x2, because it is perpendicular to y2, so it will not have any component along y2, right? So one component must be along z2, other component will be in this direction, right? Which is opposite to x2, correct? And we also know that x2 and x3 are the same, right? Which means psi dot will have a component in the negative direction of x3, correct? So what is the component along z2? The component along z2, psi
Psi
dot
dot
along,
cos.
yes, psi dot cos theta, right? And then the component along negative x2 or negative x3 would be psi dot sin theta. So we can write psi dot sin theta, right? As we write the expressions of q and r, you will find that theta dot does not have any component. And that you can see from here also. See, theta dot is along y2, correct? Y2 is perpendicular to x2, correct? And x2 and x3 are the same. So theta dot will not have any component along x3. Next, we are going to write the equation for q. We know phi dot does not have any component because phi dot is along x2 or x3 and x2 is perpendicular to y2, right? And theta dot, let's see, q is okay. Q is phi dot is along x3 only, so q is along y3. Okay. Um, so we can easily see from theta dot that it will have a component along y3, right? What is that component? What is the angle? I have put it in red.
Phi is
Phi,
an.
right? Phi is the angle, correct? So theta dot cos phi will come, right? So theta dot also have another component. So one component is along y3. Now see, theta dot is along y2, correct? y2 is perpendicular to x2 and x3. So theta dot must have a component along y3 and z3, right? You see what I'm saying? One component is along y3, right? How about the other component? Now theta dot is along y2, correct? y2 is perpendicular to x2. x2 and x3 are the same, correct? So one component will be along y3, another component will be along z3, right? Yes or no?
Yes, ma'am.
and that will be along negative Z3. So we write here. Okay. Next, let's consider the component psi dot cos theta, which is the component of psi dot along Z2. So this one, this component Z2. Can you tell me what will be the components of Z2? Will it have a contribution along Y3? If yes, what is that? Psi dot cos theta is the component we are considering along Z2. Z2 is perpendicular to X2, correct? So along which axis will it have two components? If Z2 is perpendicular to X2,
Z2 can be resolved in Z3 and Y3, like Z2 cos phi, Z2 sin phi is along Y3. I mean psi dot cos theta sin phi is along Y3 in the Q direction. Is it?
yes. We already have psi dot cos theta, correct?
And component of that
And
along
component of,
Y3.
yes, that will be sin phi, right? And then next is R. How about R? Somebody else, not Ajita. Somebody else. How about R? R is along which direction?
Z3.
Z3. Then what will be the components along
Uh,
Z3?
psi cos theta cos phi.
Psi dot, right?
Psi dot, psi dot.
Psi dot cos theta cos phi. Then anything else will be there? Hmm? Anything else? So this is the only component. No other component you can see.
Theta dot components will come. Theta dot. Because phi dot is perpendicular to Z3. It won't have
Hmm.
components, but theta dot will have.
Hmm. And what is that? Theta dot is along Y2, correct?
Theta dot sin phi.
Theta dot sin phi, it is in which direction?
Uh, Z3.
Z3, positive or negative?
Negative.
So this is so these are the three components. I have written the equations of P, Q and R as a function of color angles and their derivatives. Now we can put this in a matrix form, right? So using these equations we can have a matrix representation. So I'll give that. So let me write the equations once again. Q is right. Now the place of PQR we can now put omega. And then on the right side we have phi dot, theta dot, and psi dot. So this is the matrix we have got, right? Now we are interested in finding this one, correct? You've got this one using sensor measurements and using the Euler angles at the previous time instant we can form this matrix, right? So let's call this A matrix and phi dot, theta dot, psi dot is equal to A inverse from this way to omega 1. Now drop the subscript and superscript for clarity. But you have all these subscripts and superscripts, okay? Beta alpha alpha will be there. Since I don't have space here, I just put omega 1, 2, 3. Okay? So this is the equation that gives the time derivatives of the polar angles. Okay? So using numerical integration techniques we can integrate these differential equations and find the Euler angles at other points in time. But while doing the integration, we should keep in mind that the integration step size should be small. Otherwise, we will incorporate errors while doing the integration. Okay. Next, I will note some advantages and disadvantages of Euler angles. Now here, under advantages, we can say that Euler angles are intuitive. We can easily visualize the rotation, right? So as we go from one frame to another frame by applying 3 successive rotations, this actually helps us visualize things. So Euler angles are intuitive, and that's why they help us for debugging purposes. Okay, so they are used as debugging tools sometimes because they help us visualize things. I'll also give you an exercise on Euler rotations, and that will help you visualize things when you find the Euler rotations to go from one coordinate frame to another. I'll just give you the exercise after noting the advantages and disadvantages. So the Euler angles are intuitive. We have only 3 differential equations. Later for the coordinate transformation matrix, we will see that we have 9 differential equations, but for Euler angles we have only 3 differential equations. Then disadvantages, the differential equations are nonlinear. We don't have linear differential equations. There is a singularity, and this is an important limitation of Euler angles. Singularity at plus minus 90 degrees pitch in case of 3 to 1 sequence. Then the order of the rotations is important. Okay, not suitable for mathematical operations. So either we need to find quaternions or coordinate transformation matrix for Euler angles to do the mathematical operations. Okay, so these are the advantages and disadvantages of Euler angles. Any question on Euler angles?
No, ma'am.
Okay, next I will give you an exercise. Find the Euler rotations oriented any different. With the ECA. Assume that the user is in the northern hemisphere. Okay, the rotations will be different in north and south. Okay, so for the exercise, assume that the user is in the northern hemisphere. Okay, and you should also apply the constant on the pitch rotation. So pitch should be within plus minus 90 degrees. So let me show you pictorially what I am expecting. Here we have an ellipsoidal arc. So this is the ECF XYZ frame. Right? And then we just pick some point in the northern hemisphere. So at this point, this is north, this is east, and this is down. Right? And assume that the latitude of the user is L, geodetic latitude, longitude lambda. Okay? And you can assume that the user is on the ellipsoid. Okay, which is 0. So what you need to do is you need to find the Euler rotations. Yeah, I'll do this one. This is easier. So you need to find the Euler rotation such that the x-axis of the ECA frame is oriented along the north. Okay. Then z-axis should be along down and y-axis should be along east. Okay, now their origins are different, but do not worry about that. You just need to orient the axis. Okay, so you need to apply the Euler rotations such that the ECF x-axis is oriented along north. Okay, here along north at some latitude and longitude L and lambda. And after the rotation, the y-axis should be along east and z-axis should be along down. Is the question clear to you? So when you work on this, you will visualize the rotations and that will improve your understanding. So as you think about the rotations, your understanding improves. Okay, and you should keep in mind that the pitch constant has to be applied. So if you come up with some rotation where the pitch is more than 90 degrees, then in magnitude, then that is not the correct one. You have to apply that pitch constant and then find the rotations. The user is in the northern hemisphere. Keep that in mind. Any question? So if something is not clear, ask me. See, all this is included in the test, okay? So you need to work on this. And if you have any questions, we will try to solve the problem before the test. In case we cannot, because I don't know how things will go once we start discussing on the homework problems. In case we cannot do it in the class and you want to know, you can ask me after the class. But if something is not clear to you, you should ask me now. So do you understand what you need to do?
Yes, ma'am.
Yes,
But
ma'am.
Yes.
excuse me, ma'am.
Yes.
Earth center, Earth frame center is at the center is there, and uh, both frame have different center. So
Yes.
there is a distance between these two.
Do not worry about the locations of the origin, okay? You just need to align the axis.
Okay.
So what you can do, I mean, just do it that way. You just need to apply the rotation in such a way that the axes are aligned. X will be pointed along north. So you just think of the orientation. Okay. Origin can be at the center, but you can choose the rotations in such a way that X will be pointed along that local north. Correct? That can be done, right? You just need to find the rotations. And the latitude and longitude have been given, so they will be functions of latitude and longitude. Okay?
Yes, ma'am.
Any other question? Fine. Next we'll start the second method, which is the coordinate transformation matrix. The coordinate transformation matrix can be used to find the attitude, the orientation of one frame with respect to other. And the notation is this. So this is the coordinate transformation matrix uh, that gives the orientation of the alpha frame with respect to beta frame. Okay. Now using the coordinate transformation matrix, we can do one more thing. We can change the resolving axis of a vector. So let's say this is a vector and we have this. So beta is the reference frame, alpha is the object frame. The x is the vector related to the alpha frame with respect to beta frame, and gamma is the resolving frame, right? Now this vector is resolved along the axis of gamma. Suppose we want to change gamma to beta, then what we need to do is we need to multiply this coordinate transformation matrix from gamma to beta, and then we'll get the vector resolved along the axis of beta. This multiplication alone does not change the reference frame. It just changes the resolving frame. So by multiplying the coordinate transformation matrix, suitable coordinate transformation matrix, we can also change the resolving frame of a vector. So this also provides, the coordinate transformation matrix also provides a means to change the resolving axis of a vector. So this is an additional thing that we can obtain using the coordinate transformation matrix. Okay. Now we saw that if we apply 3 rotations, we get we can go from one frame to another. And then here in the second method, we see that mathematically if we multiply or using the coordinate transformation matrix also we can find the attitude of one frame with respect to another. So what is the relation between the two methods, Euler angles and the coordinate transformation matrix? Each of the Euler angle rotations can be represented by a corresponding coordinate transformation matrix. So first we applied in the 3-to-1 sequence, first we applied the your rotation. So there is a coordinate transformation matrix corresponding to your rotation. Okay. Then we applied the pitch rotation. So there is a coordinate transformation matrix for pitch, and then finally roll. So each of these rotations, yaw, pitch and roll, can be transformed into a coordinate transformation matrix, and if we multiply them from right to left, the first rotation should be put on the right and the last one should be on the left. So we need to go in this direction. Then only we will get the final coordinate transformation matrix. So earlier we found the Euler angles, right? The Euler attitude, beta alpha, alpha frame with respect to beta frame, and we had the three angles, right? Phi, theta and psi. Phi, theta and psi. So the psi rotation will give this coordinate transformation, then theta rotation will give this coordinate transformation, and then phi rotation will give the third coordinate transformation matrix. And if we multiply all these matrices from right to left, we get the final coordinate transformation matrix. Now let's quickly see how this psi rotation can be transformed into a coordinate transformation matrix, and the same thing can be done for pitch and roll, which I leave as an exercise. I'll just do here for your rotation, and you can can find the coordinate transformation matrix for pitch and roll. Okay. Here rotation means we are applying the rotation about the z-axis. So any vector that we resolve in this coordinate plane x, y, z will not have its z coordinate change, because after the your rotation, because the z axis remains the same, right? It's only the x and y coordinates that will change, correct? So let's consider only x and y. So after the rotation, we have mu x prime and y prime. Now our objective is to find x prime and y prime in terms of x and y. Okay, and we know that z prime is equal to z. The z coordinate does not change. Okay. So this angle is psi, right? And let's say this is the point. And this x coordinate. This was the x coordinate. Oh, sorry. This is x. This is x. And this is y. In the same frame, same point. So this is y prime, this is x prime. Right? Now what we want to do, we want to find x prime and y prime in terms of x and y. So let's draw these perpendicular lines. Okay, and what is x prime? So let's call this O. This is A, B, C, D, E. So x prime is equal to AD plus ED, correct? What is ED? ED is equal to BC. So x prime is equal to AD plus DE, right? So DE is equal to BC. What can we say about BC? What is BC equal to?
Y sin phi. Y sin psi.
Y sin psi, yes. Why only Ajita is telling? How about AD? What is AD equal to? I want a response from someone else who has not responded, not given any answer. Responded means no answer. So what is AD equal to? Hmm? What is AD equal to?
And x cos psi minus.
Minus. AD is the length, right?
Yes, ma'am.
And
AD is equal to AE minus BC, and AE will be x cos psi minus y
E is
sin.
x cos psi. I am confused. You see what is x? What is x? What is written as x? This is x. Right? So what is AD? What is this angle? DAB. What is this angle equal to? DAB. Hmm?
It is psi because AE is
No, I do
perpendicular.
not want. I do not want to hear from you. You only have been answering. No, let other people also answer. What is DAB? Somebody else.
Psi.
DAB is psi. Then what
X
is
cos
AB?
psi.
X cos psi. So AB is x, right? AB is x. Then AD is x cos psi. Right? How will you find y prime? So you need to draw some perpendicular lines suitably. So from which point will you draw these perpendicular lines? From here. So let's call this F G H I. Y prime is equal to what? What is AG? What is this angle? FAG. FAG is what? What is FAG? Sujit, what is FAG?
It's psi.
Psi. Then what is AG?
AG.
What is AF? Tell me what is AF? What is this? AF? Do you know AF or not? AF is given or not?
Can I tell?
No.
Ma'am, it's Y.
Why are you telling? Okay, it's Y. AF is Y. Then, Sujit, what is AG? If AF is Y, what is AG?
Y cos psi.
Okay, then what is the other component? We are interested in AH, right? AH is equal to AG minus HG. We have already found AG, correct? AG is this one. So we need to find HG, this one. What is this equal to? Nilal, are you there? Is Nila there? Yes
Hello.
or no? Yes, Nila. Can you tell me what is HG? HG is parallel to this line.
Yes,
Correct?
Fi. Yes.
Fi. Then what is Fi equal to?
X cos X sin phi.
X sin phi. So when we are subtracting HG, so we have X. No, phi. We are using sin. Correct? So if we have found both X prime and Y prime, now we can put this in a matrix form, correct? And that will be the coordinate transformation matrix for psi rotation. So we have so this is the coordinate transformation matrix for your rotation. Okay. Now, if you follow the similar approach for roll rotation, pitch rotation, you will find that the coordinate transformation matrix is, you are doing pitch rotation. So let me put all the matrices together. Okay. Cos theta minus sin theta, sin theta, cos theta. You need to draw those perpendicular lines properly, okay? Then only you will be able to do this. Cos phi, sin phi. So we have all the coordinate transformation matrices, and if you multiply all of them, you will get the final coordinate transformation matrix from beta to alpha. Okay. Next, discuss some important properties of the coordinate transformation matrix. The first one is its inverse. So, what is the inverse? Now, see here we have applied first psi, then theta, and then phi rotation, right now. And then from Euler rotations, we know that if we want to go back to let's first do this one. We want to go back to the beta frame from alpha frame. So what we need to do, we know that if we want to go back to the beta frame from alpha frame, we need to, one option would be to reverse the sequence, right? So earlier we did psi, theta, phi. Now what we have to do, we have to do minus phi, minus theta, minus psi, correct? Right? So first we did that your matrix, then we have the speech, and then we have the role, correct? So this took us from beta frame to alpha frame, correct? Next, we want to go back to beta frame. So here we want beta frame only. What we have to do, you have to use this one. So this one says first roll rotation. So roll rotation, then we have to do pitch, and then we have to do yaw, correct? You have to reverse the sequence. Now you just see, if you multiply roll rotation, so first roll has this matrix, right? The second roll will have phi negative, correct? So if you multiply the two corresponding matrices, so you have 1 0 0 0 0 cos phi sin phi, then here minus sin phi cos phi, right? And then the second roll matrix is what? Again 1 0 0, but phi is negative. So I'm just writing C phi, phi negative. This will be minus S phi, correct? This will be S phi, and this will be C phi. So what is the product equal to? Just see one. Let's say the second row. If you do the computation, you'll find that this is identity matrix. So these two will give identity matrix. Then similarly this and this will give identity matrix. This and this will also give identity matrix. Right? Right? Now this one, So this matrix, up to this we can write C beta to alpha, and this side we write C alpha to beta, correct? C alpha to beta, right? So from this we can say C beta to alpha. C alpha to beta, on the left side you have C alpha to beta, and the right side you have C beta to alpha. This is equal to identity, right? Now if you notice carefully, you will find that C alpha to beta is basically C beta to alpha transpose. You just consider each of these matrices, small matrices. So this role matrix, what is its transpose? Its transpose is nothing but this one, correct? Then similarly for pitch and yaw. And you also know that if you have a matrix which is the product of two matrices, its transpose is B transpose A transpose, correct? So we need to take the transpose of each matrix and then multiply them in the opposite order, right? This is how we take the transpose of product matrix, right? And this is what actually we are doing on the left side here. So each matrix is transposed and then we are multiplying in the reverse order, correct? So if you have C is equal to A, B, D, then C transpose is equal to D transpose, B transpose, A transpose. And that is what we have done here, right? So you had E of each role, then E of each role. And this role matrix is the transpose of this role, right? That is what we are showing here, correct? Right? So from this, we can say that C alpha beta is equal to the transpose of C beta alpha, and these two, the product of these two is equal to identity, correct? So from this equation we can say that C beta alpha is actually inverse of, right. Yes, I have written this one alpha beta, so I will skip alpha beta. And then from this equation we can write C alpha to beta is actually, right? So if we equate these two, we see that the transpose of the coordinate transformation matrix is its inverse. Right? So basically, for any arbitrary coordinate transformation matrix, transpose, and this is also equal to C alpha beta. So if we take the inverse of a coordinate transformation matrix, we go back to the original frame. So beta to alpha means we went from beta frame to alpha frame, and if we take the inverse, we actually going from alpha frame to beta frame, right? Okay. Next, you have an exercise. Show that show that a coordinate transformation matrix, instead of writing coordinate transformation matrix, I just use C beta alpha. A coordinate transformation matrix has 3 degrees of freedom. What do I mean by this? So this is a 3 by 3 matrix, right? 3 by 3 matrix means it has 9 elements, correct? Now of these 9 elements, any 3 elements, you can choose freely. So if you pick these 3 elements, the other 6 elements are related by some equation. So they are automatically determined from the equations. So any coordinate transformation matrix has 3 degrees of freedom. You need to show this. Okay. Next time. Yes. So suppose we have a beta frame. Okay. And we have another alpha frame. Now we have seen that using Euler rotations we can go from any beta to any alpha frame, but we need to apply 3 successive rotations. Instead of applying 3 successive rotations, it is possible to find an axis, okay? And about this axis, if we apply just single rotation, we can go to alpha frame. So we have this beta frame, right? Now if we find an axis such that about it, if we apply only one rotation, we can go to the alpha frame. This axis is called the axis of rotation. So about this axis of rotation, we just apply any, so I don't want to use phi theta psi, maybe gamma, some rotation gamma, and that will take us to alpha frame. So this axis is called the axis of rotation. Later we will see that using this axis of rotation, we define the quaternions and the rotation vectors. Okay. Now this has an important significance. This axis of rotation is the only, so we have a unit vector along this axis of rotation. Let's call this unit vector E beta. Now this is the only vector which remains invariant in both beta and alpha frame. What does it mean? So if we resolve its components along beta frame and then resolve its component along alpha frame, we'll find that the components are the same. So this is the only vector which remains invariant in both the frames. So its components are the same in both beta and alpha frame. Okay. Right. So we can write C beta alpha E beta alpha is equal to, as per definition, and we know that this is equal to this E beta alpha alpha is equal to E beta alpha beta. So E beta alpha beta. What does it imply? See, this is a matrix, this is a vector, and this is a vector. So what can we say from this equation? What kind of equation is this? So it's like Ax equal to
Eigen.
x. So it has one eigenvalue which is equal to unity. So always a coordinate transformation matrix has an eigenvalue equal to unity. Okay? Okay? So suppose we have been given a vector x, beta alpha, and it is resolved in some frame gamma. Okay. Now we also know the vector beta alpha resolved in frame beta. Okay. Now let's take another vector which is non-collinear with x, and we also know the beta. Okay. So here we need to multiply gamma to beta, right? And we want to find this one. We do not know this one. So this is also an exercise for you. You should think how we can find. So x and y are two non-collinear vectors. Okay? They are not parallel vectors. Two non-collinear vectors. Okay? And we know their components in both beta and gamma frames. So they have been resolved in both beta and gamma frames, and we know. Okay. Our objective is to find this one. We do not know this one. We do not know the coordinate transformation matrix from gamma to beta. So we want to find this using these two non-collinear vectors. How can we do? So this is a 3 by 3 matrix, right? So this also has to be 3 by 3. Okay? So this means we need to find an element, a vector here and a vector corresponding vector here. So what can we do to find this missing vector? Okay. This is an exercise. So given two non-collinear vectors in both beta and gamma frames, how can we find the coordinate transformation matrix? Okay, I'll just state one more property, and after that we'll take a break. and after the break we'll discuss more problems. Suppose this is the coordinate transformation matrix from gamma to beta, and this one is beta to alpha. So if we multiply from right to left, we basically get the coordinate transformation matrix from gamma to alpha. So this is the matrix from gamma to beta, this is the matrix from beta to alpha. So if we multiply from right to left, we get the final coordinate transformation matrix from gamma to alpha. But the order is important. If you multiply this matrix on the right, you will not get it. So you have to keep multiplying from right to left. Okay. So this way, by multiplying the successive coordinate transformation matrices, we can get the final coordinate transformation matrix. Okay, that's it for today as far as theory class is concerned. Let's take a 5-minute break. Uh, In fact, I'm giving you 6 minutes break. And after the break, we are going to discuss the tutorial problems, the homework problems. We will not be able to discuss all the homework problems. Um, so what I want you to do is, you need to take snapshots of what you have done on your notebook, and then during the discussion you need to share your screen and quickly tell me how you have solved the problems. Okay, so each person will get about 5 minutes time to explain what he or she has done. This is clear? You basically need to share your screen, take screenshots, snapshots of your pictures of your notebook where you have solved the problems, and then show me by sharing your screen. Okay, so we'll have 5 minutes break. We'll continue from 12:30. Be ready with this so that when I call you, do not need to spend time on setting things up. Okay, you should be able to do this fast and show me what you are doing. Okay, so let's start. Who wants to explain first? If nobody volunteers, I'll pick somebody. Nobody wants to volunteer? Are you ready or not? How many of you are here? Nobody. Okay, Shujit. Shujit wants to explain first. Okay, fine. Do it quickly. Share your screen and show me the key steps. Do not take more than 5 minutes. Do it fast. Yes. Share the
Ma'am,
screen.
ma'am, I did the Doppler derivation of Doppler frequency.
You have to
Derivation.
share your screen. Didn't I tell you that you should take screenshots? I mean, pictures of what you have done on your notebook and share.
Then say, ma'am, first you have to upload this image from phone to the laptop. Then it will be take
Then why,
time.
why it will take time? Using
Taking the
your
picture
USB.
from the phone and uploading the image
How much
to the
time
laptop.
does that take? How much time does that take? Don't you have a USB cable?
Yes, ma'am.
Then using the USB cable it can be done easily.
Try, ma'am.
You are not ready then. Who wants to explain? Who is ready with the explanation?
Ma'am.
Ma'am, I did.
Okay, Apur. Apur responded before Ajita. So I'll ask Apur to share the screen first, explain what he has done, then I'll go to Ajita. Okay? Yes.
Yes, ma'am.
Oh,
Ma'am,
can you
so
enlarge it? Can you enlarge it a little bit?
yes, ma'am.
Yes. Hmm. Sure. Explain only the key steps, okay? Yes.
Yes,
So you
ma'am.
have written the equations, okay, fine. Then next.
Then I made a matrix out of the equations with the x and y. So you have a into x is equal to b.
Hmm.
And I did the inverse of that matrix, and that's how we get x.
Okay, fine. Next.
And next is when the true north is not known. So we have to have an additional
Theta.
transmitter.
Okay,
Yes. So here I wrote the equations,
okay.
and
After that,
1 minute. Mm, yes, so I wrote the equations, and
okay, I see. Yes, tan theta. Okay,
then I got three equations, and then I started manipulating the equations,
hmm.
and
But
from
you
there
can, yes, yes.
I got this step where I could separate the three variables, but then the variables were tan theta, y, and x tan theta. So this is
Okay,
of the form ax is equal to b. From here we can inverse a and get tan theta, y, and x tan theta.
okay, fine. You can do this way also, but there is a shortcut approach actually uh,
Oh,
that we'll discuss. Okay, fine. Next.
then other question was the Doppler effect one.
Yes, Doppler frequency. Yes.
Here the phase change is k times x, and k is 2
What is
pi by
okay? Okay.
k is the wave number,
Hmm.
and x is the distance traveled. So if we differentiate this equation, we say that rate of phase change is equal to 2 k 2 pi by lambda into the dx by dt, which is velocity. and d phi by dt is this frequency because when we differentiate this t comes out,
Okay.
and from here frequency is 1 by 2 pi times this angular frequency. So from there we get frequency is Vr by lambda,
But how can you say
and
that is the Doppler frequency? Are you saying
because
that
the
yes,
because the phi was the phase change.
phi could be the phase change because even there is no relative movement between the user and transmitter. Phase will change, correct?
Uh, yes, ma'am. Yes, ma'am.
Okay.
I put this as Vr in this equation when I
Okay,
used
dx
x.
by dt, dx by
Yes,
dt.
ma'am. Yeah, that is relative
But
velocity.
even when VR is 0 dx, because the wave travels in space, right? What is x? X is the distance traveled by the wave, correct?
Relative between the transmitter receiver.
How can you say relative? Where you are considering the relative distance? In the just go up.
I
So you
wrote
have
Vr as
written sine kx minus wt. So kx minus wt means you are considering both distance and time, correct? This
yes, ma'am.
wave is traveling in distance and time is also elapsing, correct? But
Yes,
that
ma'am.
will happen even when there is no relative movement between the user and transmitter, right? Then also the wave will travel and travel some distance, so x will be non-zero. So VR is basically the speed at which the wave is traveling, correct?
Oh, yes, ma'am. I got it.
Yeah, so think about in terms of relative motion between the user and transmitter.
Yes, ma'am.
Okay, next.
This one was y is CD equal to the radius of curvature.
Mm.
This I did not. We have to explain. I did not
You,
fully
you need to,
understand, but
yes, yes. Just tell me what you understand.
I wrote that the north and the east side, the top plane is tangential. So
Mm.
when we draw when we go perpendicularly inward, that
Mm.
would be the radius of curvature. Because if we draw a sphere here, a circle here,
Mm.
a local circle here at point C, then that circle's radius of curvature would be perpendicular to the
But
surface.
which circle? We already drew a circle that gave the north down radius of curvature, right? So that
Yes,
circle
ma'am.
was also drawn, correct? And that was the
Yes,
base fitting circle to the ellipsoid. So there can be only one base fitting circle, right?
yes, ma'am.
Then we already drew that base fitting circle and that only gave the north south radius of curvature, correct?
Yes, ma'am.
You need to think more about this. And yesterday I gave a problem on velocity term, so that will. So if you solve that first, probably you may get some insight. You need to do some visualization here. Okay.
Yes,
Yes.
ma'am.
Next.
Um, X is so this is
You
RE
show
and
me
this
the
is
equations.
H.
You just show me the equations.
This one.
Uh, okay. Yes. You need to show this. Yes. Hmm. What did you do? Show me the steps. Have you
I
read?
got it.
Yes.
I just wrote the separations here. So if this is H sine L,
Okay.
this is RE plus H cos L. Then when this is lambda, this is RE plus H cos L.
But
So this would be
cos L, so how do you get the final expression of Z from cos L? It is given in terms of something else, right? Sin L is given. You
yes
just see
sine
the
L.
Z. So how do you get sin L from cos L?
Sine L over here, H sine L.
And which one did you write cos L? RE plus H, RE plus H cos L.
Sine lambda.
No, X and Y I understood, but Z one I don't think it is correct.
Oh,
Um, mhm. Take sin L and then you have done. That will not give the final expression you have written. Whatever uh, separation you have shown does not give
Yes,
the
ma'am.
final expression you have written. So you need to show the intermediate steps. Do it
Okay,
properly.
ma'am.
Okay,
Yes, ma'am.
fine. So I'll go to Ajita. Ajita, can you share the screen?
I'll unshare.
Yes, ma'am.
Yes.
Can you see my screen?
Yes.
Okay. So this is the first problem which I tried.
Enlarge it. Enlarge it a little bit.
Hmm.
Yes. So show me
Uh,
only the key steps, okay? Rest I
okay,
think
ma'am.
I'll understand. Yes.
So this is the we should use. I mean, we don't know the orientation of the reference axis also.
No, but
So
initially it is assumed that you know, right? Have not you done that one?
that is
When
anyway two equations. We'll know x and but anyway, if I do I mean, I know that how to do that one also. But
so you did not do that. Okay, fine. Let me see what you have done with
I
theta.
I did it, ma'am. Okay, fine. Now this is a unknown reference axis. Theta is the unknown angle. I mean, as you said, I took three transmitter locations. And I know the locations like x1 y1 x2 y2 and x3 y3.
That I
And
understood. You need not explain that because I need to
fine.
explain from others, get explanation from others.
Okay,
Correct?
okay, okay. So
Yes.
yeah. So psi 1 psi 2 psi 3.
That I
I
understood. You go to the equations. Straight away go to the equations.
uh, So you can see I found the line equation, ma'am, for each transmitter, and I know the x1, y1 and angle theta, right? So that I can
Oh,
find the slope and line equation.
1 minute, 1 minute. What is that equation you have written? Y1 is equal to cot theta
These
plus.
are the slope, ma'am. Tan of, I mean, if we see the diagram.
Okay, you wrote the equation of the line. Okay.
From the line equation using slope y equal to mx plus c, so that is the slope angle. So I got everything as tan 90 minus angle. So I have written as chord of theta plus psi 1 to x1 plus c1. C1 unknown, but I know the transmitter coordinates, so x1 y1 are substituted. Then
What
I
is
got three.
y1? What is y1?
X1 y1 are the coordinates of the transmitter tr1.
Why the transmitter coordinates are known?
But we will be knowing the coordinates of the transmitter, right? I mean, with
Yes.
we will know the location of the transmitters, right?
Yes, they are known. Oh, it's
Known.
y1 and x1 are known. Yes.
So from those I got three equations and three unknowns. Theta, x, and y all will intersect at the user. So,
Yes.
but finding the x user, y user, and theta from these equations, I mean, by hand was difficult, ma'am. So
So
I found only XU. Uh, next.
you have to
Uh,
write the equations properly so that things become manageable. Okay, fine. Next.
Next one is about the
Enlarge,
Doppler frequency.
enlarge it a little bit. I think you did something similar to.
Same only, ma'am.
You
I thought
understood
of
the problem, right? Understood the
uh,
problem.
understood, ma'am. Like we
Okay,
have to
fine.
consider the relative velocity. Okay, ma'am.
Yes, next.
The other two problems, like proving that CD equal to RE and CD equal to RE, I could imagine, but I'm not able to justify how it is equal, ma'am. And the other derivation, I was stuck, ma'am. Like in the derivation, in the middle of derivation, like I couldn't complete the derivation, ma'am. In deriving L lambda coordinates in terms of
Okay,
x y
wait.
z in terms of lambda.
I am giving you time till Wednesday. So Wednesday you need to show me, not only you,
I'll show, ma'am.
everybody. Okay,
Definitely.
everybody needs to show. Whoever has not done all the problems should do the remaining problems and show me on Wednesday. Next, Nilay. Nilay wants to explain, or Krishna or Shrujit? Who will explain next?
Yes, ma'am. Krishna here.
Okay, Krishna, can you explain what you have done?
Yes, ma'am.
do it fast, okay? Share
ma'am.
your screen and do it fast.
Ma'am, this is the first question.
Enlarge it,
In the,
enlarge it.
sorry.
What you done? Yes.
Ma'am, actually, our both transmitter coordinates are known. So I have assumed just transmitter one location is A comma B and second one is C comma D. Similarly, R1 and R2 is the line of sight, that is length. And
No,
so,
no, but we do not know R, okay? We are making only bearing
yes, ma'am.
measurements. Yes.
Yes, ma'am. I'm calculating R1 and R2 from the this last two equations.
You are calculating
Sorry,
R1 and R2.
yes, ma'am.
How are
I'm
you
calculating R1 and
calculating?
R2. First, R1 is this Euclidean distance, A minus x.
You
In
do
this
not know
equation,
X and Y. You have to
yes,
find
ma'am. I'm
X and Y.
calculating. Yes, ma'am. First, in above two equation, x, y, and R1, R2 are unknown. And I am calculating R1, R2 from this transmitter coordinate x1 and A comma B and C comma D, because we know this A, B, C, D location. So this difference will R1
I
cos
do
psi
not
1.
understand how you are doing, okay? How many equations and how many unknowns? Can you tell me?
Ma'am, last two equation will give us R1 and R2, and if we substitute in above two equation, so we'll have
How
finally
last
we
two
have.
equations will give you R1 and R2, X and Y are unknown, right?
Sorry, ma'am, I have written wrong here in third and fourth line. This should be A minus. This is the Y coordinate difference, and last one is X coordinate difference. It should be A minus D. First one, this one is A minus D, and this is B minus C. See?
I do not understand what you are doing.
If we
You have
take
not
Y,
written the steps properly. You
sorry,
have
ma'am,
not.
I have just written
No,
just
this way do
5
not do, okay? You should write all the steps properly, and the intermediate step should also be given. Why you are unnecessarily considering range measurements or range? You have to do it using bearings only.
Okay, ma'am.
And how many unknowns you have? You have included two more unknowns, X and Y, and then R1, R2.
Ma'am, we kept
And you have considered two more equations also, R1, R2. Unnecessarily you are including R1, that's what I would say.
no, ma'am, we can
R1 and
obtain
R2.
R1 and R2 from third and fourth equation. This left hand side is I am written wrong. It should be
How can you relate the two transmitters and find R1 and R2? No user. R1 and R2 are the distances between the user and transmitter. So without involving the user, how can you find R1 and R2? Equations are completely wrong. Write them again. Use bearing only measurements. No range measurements. Only bearings. Then next.
ma'am, I am done same thing.
All of you have
Just,
done the same thing.
yes, ma'am.
Next. So think about it. You have to include the relative motion between the user and uh, the transmitter. Otherwise, there is no Doppler frequency. Doppler frequency arises only when there is a relative motion between the user and the transmitter. Yes. So
Ma'am,
this is not the way you should do homework problems. Okay. Nothing is clear. Write
just I
down
have
all the
just
steps
right and
properly.
back.
Hmm?
Yes, ma'am.
This is not how you should show the homework problems. Okay. You should write all the steps, all the equations properly, clearly, not scribbling something here and there. Even diagram should be drawn properly. What else have you done?
Ma'am, I think you will give us a question to solve in 5 minutes or 10 minutes. I was thinking about that.
I don't understand what you said. Say that again.
Ma'am, I think you will give us any question to solve this in 5 minutes or 10 minutes. That's why I didn't make any PPT or any proper note.
Then how will you explain without sharing your screen? Tell me how you can explain these equations. You have to share the screen, you have to show what you have done, then only you will be able to explain how you have derived equations. So next time I want to see proper steps,
Okay, ma'am.
a methodical approach, not scribbling something here and there. And bearing only, I mean the first problem, you have to use only bearing measurements, no range measurements.
Okay, ma'am.
Anything else you want to show?
No, ma'am.
Okay. Who will
Thank you.
explain next? Shujit or Nila? Whoever it is, do it fast. Shujit or Nila, who wants to do it? None of them wants to do, then
Yes, ma'am.
yes, do it fast. Nila is here or not?
Yes, ma'am.
So, have you done anything?
No, ma'am. I will do it and present it on Wednesday.
See, I want to see how you have solved the problems. Okay, no need to prepare any PPTs or anything. You need to write down all the steps in detail, and then that only you need to show. You are supposed to
Okay,
show
ma'am.
today. Don't think that if something is due today, you show it next time, and that is fine. No, that is not fine. Sujit, do it fast.
All right. Sorry, ma'am.
Sujit, are you doing it? Otherwise,
Yes, ma'am. I'm doing.
I cannot see anything.
Can I show me with my camera, ma'am?
Yes, yes, you can show. But next time it should be proper.
Ma'am.
You got so much time, right? So many people discussed. So much time you got now. Then also you are not ready. What is this?
Ma'am, I'm trying from the browser my computer, but it's not getting the file in downloaded folder. That is image.
I really don't understand what you are doing. From phone you have to use your browser. Why you can use Bluetooth,
No,
you can
in
use USB.
laptop I have
So
downloaded
you
in
can
the
transfer it to you can transfer from phone to your
yeah,
laptop easily, right?
yeah,
You
transfer
can
is
use
already
Bluetooth.
transferred.
So you can use Bluetooth. You can use USB cable to transfer the files from phone to laptop, right? Now after that, what else do you have to do? You just need to share the screen. So if you are not ready, then
Comment only. I'm sharing the hide share options is showing in my laptop.
so you're basically not ready. How could other people present? See, next time I'll not give you this much time, okay? You should be ready and you should straight away show me.
Now it is visible, ma'am.
I can see your screen, but I cannot see the file.
Okay. Yes, ma'am, this one?
No,
This one?
no, I can't see any file.
It's showing bad network qualities. One minute, trying.
Okay,
I think
next
it's
one is so you are not able to do it.
1 minute, ma'am. 1 minute.
Next Wednesday, we'll first discuss the homework problem. So, some of you had shown me some of the problems. You are advised to work on the rest of the problems and show me those problems next Wednesday. Okay, and then once all of you show me all the problems, we will do a final discussion. That will be the first thing next Wednesday. Okay, and if needed, we will have half an hour extra class next Wednesday. Is that fine? No, let's see. Next Wednesday is. Yeah, so is this fine if we have half an hour extra class next Wednesday? So 10 to 11 is the scheduled time. So can we have a half an hour extra class? 10 to 11:30. Is that fine?
Ma'am, we have CFD class from 11 to 12.
You have CRD class. Okay.
Uh,
Okay, how about Thursday? 9 to 10:30?
for me, it is okay, ma'am.
How about
But I
others?
don't know those.
9 to
Okay,
10:30?
ma'am.
Yes,
Apul?
ma'am.
Nilay? Okay, then we'll have half an hour extra class on Thursday. Yes, quickly explain. You have done the same thing. I do not want to see this. Next. So next time what you do, Sujit, you should, just before the class, you should share the homework problem. You should email me the
Okay.
homework problem so that I can see it on my screen. And then you can
Okay.
explain what you are doing.
Okay.
This is the only problem you have solved? No other problem? Only one problem you have done?
Yes, ma'am.
Why? Other problems, why didn't you solve other problems?
Other problems, ma'am, I'm trying to solve, but I'm not getting.
What is the problem with bearing measurements? Can't you write the tan equations? Didn't you get some idea today from what people showed? Have you got any idea? Or you did not pay attention to that?
Yes, ma'am.
Yes, then do that. Do that and show me on Wednesday. Okay?
Okay.
Okay, fine. That's it for today. We'll continue on Wednesday. Wednesday first, we'll go over all the homework problems, and then I'm not sure whether we'll have time left. But we'll first solve all the homework problems. So today I give you some more problems. But first work on the previous problems and see if you can solve the newer problems also. Okay? That's it for today.